Hey there, guys. Today I'm going to do physics passage 1 from the official guide. That's on page 138. Again, this when I'm working through these passages, it's just I'm thinking that maybe you want to see how I think about things, and maybe you'll pick up on some sort of a pattern, or maybe you'll um, pick on some sort of knowledge that I have along the way. Maybe it'll be useful. But I'm just going to go through this passage. I haven't done the questions before, haven't even read the passage yet. So I'm going to take a couple of minutes and read the passage. I would do it in out loud voice, but I don't think that I'll be able to concentrate well if I do that. So I'm going to just read the passage, and then I'm going to head into number 1. I'll probably edit out that time so you don't have to wait, though, okay? So I'll see you in a couple of minutes after I... Now remember, it'll be 1 minute is about what the time will take, because I mean, when you're reading science passages, don't take too much time trying to read the passage. Just skim through it, get the basic idea, remember where stuff is, and then go for it afterward, okay? Because if you need to look up anything else, or if there's anything that you don't know, you can probably find it in the passage as long as you know where it is pretty quickly. That's the whole purpose of reading science passages. Only take about a minute tops to look through those, okay? Hey guys, just breaking in really quickly. I read that first paragraph, and it basically didn't give me any real science information. It just predicted a whole bunch of disaster. So all I remember for that first one is disaster can come from global warming. The second one starts to increase this idea of like heat transfer from the sun to the earth, and then from the earth back out into space, heat loss. So that's nothing too crazy. That's the first one that has to do with science. Okay, so this third one's kind of a hodgepodge. They talk about how CO2 um, absorbs the heat, and then transfers it to other places like the it's in the atmosphere, so to glaciers and then to the ocean and such things. It talks about a couple of consequences of that, and then it talks about how we detect these temperature changes. So detection theory. So that's pretty much all I got from there. It looks like this is your basic, the science of whatever. They just described you the science behind some sort of thing. Here we've heard about global warming before, so they're just describing their understanding of the science of global warming. That gives you a bunch of fodder for questions that they could ask. They could ask about surface temperature. They could ask about temperature in general. They could ask about, looks like heat transfer, right, or radiation detectors. So they could ask you a radiation question. Balloon-borne thermometers. So they could ask you about, why things float. I mean, there's a million things that they could ask you. Then they threw a bunch of stuff in that first one about disease and things. So I mean, there's they've introduced so many topics they could ask you a bunch of questions. Don't get worried about it though. Usually the answer is either in the passage or you will have learned it from the program. Let's look at one. Which of the following best explains why a warmer atmosphere will have a higher humidity? Okay, interesting. Why? So that means that there will be more water in the atmosphere if it has a higher humidity. So why would a warmer atmosphere have a higher humidity? Let's look at the answer choices. More heat available for evaporation from the oceans. Are they saying more heat will cause evaporation to the oceans, or more heat will come from evaporation to the oceans? Because I mean, more heat going to the oceans and then causing more evaporation would make more sense to me. So I like A, kind of. I'm not sure about that wording. The air is less dense, leaving room for evaporated molecules. No, because if the evaporated molecules were filling in that less dense area, then the density wouldn't have actually changed, right? That doesn't make any sense. So I'm going to skip B. I'm going to say probably not for B. The air has less pressure over the oceans, allowing easier evaporation. That actually does seem kind of reasonable, because if it's warmer, well, actually, no, if it's warmer, would that mean it would have less pressure? Let's think about this. PV equals nRT, right? And that's for gases. So if I have a hotter gas, then am I going to be exerting more or less pressure? Well, I should be exerting more pressure. So, I mean, I think that in general that doesn't make sense. I know that there's no pressure squeezing down from the top except for the gravity, so I don't know. I still feel like increasing temperature would probably increase pressure, because if you increase the one, then you'd have to increase the other. Do you like how I'm going for the chalkboard effect here? Doesn't look like a chalkboard? Cool, right? So probably not C. I still like A best. Higher temperature air causes stronger winds to evaporate over the ocean. I don't think the wind is what causes the evaporation. It may allow for more or something, but I feel like A is probably the right answer, so I'm going to put A right here. I sure hope that's right. Okay. Sometimes I feel that way a lot with these ones, but I mean the other three answer choices I wouldn't feel comfortable putting them. I feel most comfortable with A. So 2. The oceans and atmosphere exchange heat mainly by conduction. What microscopic process is responsible for this exchange? All right, K, heat conduction. I love heat conduction. If it's conduction, they tell me what microscopic process is responsible for conduction. I don't even care about the oceans and atmosphere anymore, right? It's just what causes conduction. It's 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 bouncing. It's transferring energy between atoms, right? So is it electronic transitions? No, because that would be radiation. Is it elastic molecular collisions? That seems about right, because they transfer kinetic energy completely in elastic collisions. So, if that doesn't make sense to you, then you need to look up elastic collisions. Atomic ionization, well, that's radioactive decay, or that could be ripping off electrons or something like that as well. It doesn't have to be radioactive decay. But I mean, that doesn't have so much to do with like heat transfer. That has to do with conduction, has more to do with radiation. So, probably not at the one. Molecular dissociation, that's also not conduction. Conduction is bouncing molecules. So I'm going to go with B. Let me put that up here, B. Okay. Global atmospheric circulation is driven by differences in air temperature at different latitudes. So talking about convection, it looks like. Equatorial regions are heated more by the incident sunlight than our polar regions because, okay, so why? I think they've taught me this in like since 5th grade, something about directness. So why are equatorial regions heated more by sunlight than polar regions? This is because the Earth rotates. No, that doesn't change the polar dude's relationship with the equator, so that's a no. The atmosphere absorbs more sunlight in the equatorial regions. That might make sense. I mean, that would, if it absorbs more sunlight, then it certainly would be hotter. So that seems reasonable. The amount of greenhouse gas in the polar regions is less than the equator, and that doesn't make any sense. They would have given me a reason to know that in the passage, but I don't have any reason to base that off of from the information they gave me. I don't even know how I could prove that to be right, so I don't like C. The sunlight is incident on Earth at smaller angles in the polar regions. Alright, so now it's either the atmosphere absorbs more sunlight in the equatorial regions, or it's the sunlight is incident on the Earth at a different angle in the polar regions. I'm trying to decide between the two. The one that they told me since like 5th grade is that it's because of the angle of the sunlight, and then other angles get reflected off of it. So I think I'm going to go with that one. What else do I know about atmosphere and absorption? What's the net effect on the sea level when icebergs melt in the ocean? This is like, from the Altius question, remember where Lauren asks, what if the ice cube melted, right? In the glass, remember nothing happens? So, if the icebergs are floating on top of the ocean, then the melting ice cubes won't do anything. And if you don't remember that from your lesson, then you should have gone over that with your tutor. Ask your tutor about it, or write it down in the comments afterward, and I'll give you an example. Sea level rises, no. The sea level lowers, no. Sea level remains approximately the same because the floating iceberg displaces its weight of water. That's exactly the reason. Okay, if that doesn't make any sense to you, then you need to talk to your tutor, because we talk about that in golly, I think it's physics 2. I mean, I think it's chemistry 2. But yeah, I'm gonna put C. Greenhouse gases absorb infrared radiation in what kind of process? Oh, this is exactly like question 2. So this is just, instead of conduction, it's radiation. That's funny. So when you absorb, where does the heat go? Where does the radiation go? It's absorbed in the atom, right? So is it in molecular, so is it in atomic transitions? That would be like radioactive decay, right? Transitioning from one element to another, so that doesn't make sense. Vibrational and rotational transitions. That's actually what heat is. So if it's going to absorb the radiation and become heat, then that's exactly how it's going to be absorbed. So I like B so far. Molecular dissociation. No, that sounds more like splitting molecules, and that's not absorbing heat. Usually you release heat when you break bonds. Molecular dissociation, with what I just said, and phase transitions. I don't know what that even has to do with like relating radiation to a gas, because the gas isn't changing, right? So it looks like it's mostly going to be molecular motion, so I'm going to put B. Alright, let's check. A, check, good. 2B, check, good. 3D, check, good. 4C, check, good. 5B, nice. Okay. Well, that's a wrap. Thanks for listening. I hope this is useful to you.